Hi everyone, in this video we are going to discuss dimensional analysis. Now, we've discussed it before, but just as a reminder, dimensional analysis is a way to convert one number of a specific unit to an equivalent number of a different unit. So maybe we want to go from kilograms to pounds, or feet to inches, or centimeters to meters, or something of that sort. Dimensional analysis is just a strategy or a way to help us go from one way to another. So let's talk about this in terms of the air we breathe or the pollutants that we breathe. So let's say someone in Austin, maybe the weatherman or whatever, tells us that the concentration of ozone for today is equal to 0.12 ppm. Now, hopefully at this point in the unit, you see that number and go, oh, that's absolutely terrible, because you remember our air quality standard is 0.075 ppm for ozone. So what we want to do now is look at this number and try to determine what that means on a molecular level. So what we want to do is answer the question, how many ozone molecules are inhaled per breath. And this would be just for our specific example. This is not a global term, obviously. So at a concentration of 0.12 ppm, how many ozone molecules would we be, in theory, inhaling per breath? So the first thing we need to do is translate this ppm into something that is a little bit more meaningful for us. So what we know is that means that 0.12 parts per million, or molecules of ozone, exist in every, so we said million, right? So every million molecules of air. So this relationship, or the equivalent of 0.12 molecules per every 1 million of air, is going to be very important in just a second. So what we want to start off with is something that I would actually have to give you. I'd have to give you this information in the very beginning. And I would tell you that one breath is equivalent to 2 times 10 to the 22 molecules of air. And this is the piece of information we would actually have to start off with in order to solve this problem properly. So I'm going to scroll up just a little bit to give us more space. So let's start off. We know we're trying to solve for ozone molecules per breath. So I'm going to start right off here by putting breath in the bottom. So one breath, which means that I'm going to just have to start off with 2 times 10 to the 22 molecules of air. So again, I like to use these train track methods. You don't have to do it, but this just works for me. It's what I learned my sophomore year of high school, and I stick with it. So now, we know for every 1 million molecules of air, we have 0.12 molecules of ozone. So we have molecules of air here on top of our dimensional analysis part. So that means we need to put molecules of air on the bottom. So molecules of air. We said for every 1 million molecules of air, we have 0.12 molecules of ozone. So very, very small amount, really, if you think about this. So now what we can do is try to cross out any of our units that are equivalent. So one's on the top, molecules of air is on the top here, and molecules of air is on the bottom there. So those two can cross out. Now what we're left with is molecules of ozone over one breath, which is what we're actually trying to solve for. So we're ready to go. We can just type this in the calculator. So what we would do is 2 times 10 to the 22nd times 0.12 divided by 1 divided by a million. And if you do this properly, you can enter it into your calculator and it would give you an answer of 2.4 times 10 to the 15th, and these are molecules of ozone per every 1 breath of air, which is a lot, right? So in every 1 breath, in theory, any Austinite would be breathing in 2.4 times 10 to the 15th molecules of ozone. And that's way, way, way more than we should actually be inhaling on a regular basis. So what I want to do now is turn it over to you and actually ask you to solve a similar problem. So for this one, draw a line just to separate it, I want you to figure out how many molecules of carbon monoxide are in one breath. To do this, I want to remind you of our carbon monoxide standard, which is 9 ppm. Okay, and so please try to figure out how many molecules of carbon monoxide exist, in theory, in 1 breath of air. Go. All right, did we figure it out? Hopefully we did, but in case you didn't, that's all right. We're going to go through it together. So we're going to start off in the same standpoint that we did with the last problem. So we said that we have 2 times 10 to the 22 molecules of air per every 1 breath. Now, just like in the last one, we need to now convert our molecules of air to our molecules of carbon monoxide. So I'm going to put molecules of air on the bottom, and we're going to put molecules of carbon monoxide on the top. So now we have been given our conversion right here. For every 9 molecules of carbon monoxide, we have 1,000,000 molecules of air. So 1,000,000 goes down here, and then 9 is going to go on the top. So every 9 molecules of carbon dioxide to every 1,000,000 molecules of air. So molecules of air is then going to cancel out because we have one on the top and one on the bottom. Then we just type it into our calculator, and if we do this properly, we should get the right answer, which is 1.8 times 10 to the 17th molecules of carbon monoxide per every 1 breath of air. Now, if you didn't get this answer, there's one major thing that you could probably be doing wrong, and it could be that you're using your calculator incorrectly. So let's go through how you should enter this into your calculator properly. So if you are doing 2 times, like on your calculator actually, if you're doing 2 times 10, then the little caret to 22, stop right now. You're doing that incorrectly. Don't use that. Your calculator gets kind of confused. It doesn't understand that theory. So what you need to do is type it in to your calculator in scientific notation so that your calculator knows this is a set. We want to keep the 2 times 10 to the 22nd together as one number. So how you do that? You do 2. Then you use this little button called EE. Now, I typically have to use second EE in order to do that, so let me show you. So here I've typed in a 2. I'm going to go to my second button right here, and then I'm going to go to my EE button, which is actually my comma button here. And so now hopefully we have a 2 and then an E, and then because my exponent is 22, I'm just going to write 22. So in my calculator, in case this doesn't show up, I have 2E22. I am telling my calculator this is scientific notation for 2 times 10 to the 22nd. All right, so we type that into our calculator. Then we go directly to the next piece, which is times 9 in the numerator. So we're just going to go times 9. Let me make sure I have that right. So we have 2E to the 22nd times 9. Now, everything in the bottom, you just divide by it. So we're going to divide by 1 breath, so divided by 1. Then we have to divide again by 1,000,000. So divide by 1,000,000. So 1, 1, 2, 3, 4, 5, 6. And then we hit enter. We get an answer in scientific notation. It spits it out as 1.8 e to the 17, which we know means 1.8 times 10 to the 17th power, which is your correct answer. If you do not understand what I'm talking about with a calculator, stop immediately and talk to your instructor, your teacher, because we need to get this figured out. You have to be able to use your calculator properly. Okay, good luck. Take care of yourself. Have a great day.